guys, welcome back to Pre-Calc and Trig. Today we are talking about P6 complex numbers. And so we're going to talk about what a complex number is. So complex numbers, operations with complex numbers, conjugates and division, and then talk about complex solutions, like what that means with quadratic equations. So let's talk about what a complex number even is. And so a complex is any number that can be written in the form a plus bi. So I is imaginary number, okay? So as long as it can be written in that form, it is a complex number. So a and b are real numbers, and the real number, the a is the real part, and the b is the imaginary part. And then a plus bi is standard form. So any of these numbers, so like -6 plus 0i, that can be written as a complex number. 5i, like 0 plus 5i, so like your 0 would be a, your 5 would be your b, and then you have your imaginary. So this is, some just copied and pasted from your book, some definitions over complex numbers. So basically, again, this I right here represents your imaginary, and this is your real number. And then I kind of want to talk about this. So if we have I to the first power is just I squared is -1. We will use this in all of our operations. We're going to talk about that. But if you see I squared, that's the same thing as -1, and you will change that. Okay, I to the third is the same thing as I times I squared. Well, we know I is I. I squared is -1, so I times -1 is -I. And then I to the fourth, I squared times I squared is -1, -1 times -1 is 1. And this is like a repeating pattern that happens. So like I to the fifth would be I to the sixth would be -1, I to the seventh would be I to the eighth would be 1, and it just keeps repeating those 4 over and over and over again, okay? But the number one thing to remember is I squared is the same thing as -1, okay? So let's look at some more definitions. So again, if you have the real number a, and then your imaginary is the bi, and so these would be the same thing. So if we had, they're equal, so if we had x plus yi is equal to 2 plus 5i, so your x would be 2, and then your y would be 5, and this is also your a, and this is your b, okay? If and only if x equals 2 and y equals 5, and so those are kind of just placeholders to just practice looking at those numbers. Okay, so let's look at some operations. So first, let's do addition and subtraction. So we have if a plus bi and c plus di are two complex numbers, then if you take your sum, if you look here, these right here are your reals, your a and your c, so we can combine a plus c. And then for your imaginary, we have b and we have d, so bi and di, so since those are both your imaginary, those are like your like terms, and b plus d would be your b in front of your I, okay? And then the same thing for your difference. So if you did a plus bi minus c plus di, you would do your a minus c. Those would be your like terms. And then you would do your b minus d. Those would be that term, okay? And so you have to watch, especially for your subtraction, your difference. Those are always the big tricky ones. You have to watch that you distribute that negatives through. And what your book does is they group them and then simplify. I just like to look at them and simplify, but I'll talk about that with this first problem. So we have a 7 minus 3i plus 4 plus 5i. And so we can combine your like terms. Your real numbers can combine, your imaginary numbers can combine. So for our real numbers, we have a 7, and we're gonna be adding it to a 4. And so what they did is they put 7 plus 4. Okay, and then if we talk about our imaginary numbers, we have a -3i plus a 5i. Well, we can combine those coefficients, those b's, -3 plus 5 to go in front of I. So 7 plus 4 is 11. And then we have -3 plus 5 is 2i. I usually go straight from here to here, but if you need this extra step in the middle, go for it. That's okay. There's nothing wrong with doing too many steps. So now let's do a subtraction, a division. We have to watch out, or not division, subtraction, the difference. So we have our imaginaries, we have a 2 minus 8. Well, 2 minus 8 is negative 6. So that would be negative 6. And I'll go ahead and write 2 minus 8. Okay. And then it would be, I'm not gonna write it. 2 minus 8 is negative 6. Okay. And then our imaginaries, we have a negative 1 minus a 3. So negative 1 minus 3. So keep change would be a minus 4 and then I. Okay. And so all you do, negative 1 minus 3, you have to watch that because a lot of people be like, oh, okay, well, that's 2. Well, no, because you have to distribute that negative here to that negative 3. So this would be your answer, negative 6 minus 4i. Okay? So that is addition and subtraction. Now let's talk about multiplying complex numbers. And I put this here, right here. This I squared we're going to be using. Okay, so our first, we have 2 plus 3i times 5 minus i. So this is like FOILing, okay? So we're going to multiply 2 times 5, and then 2 times negative i, and then 3i times 5, and then 3i times negative i. So 2 times 5 gives us 10. 2 times negative I gives us negative 2i. And then 3i times 5 gives us 15i. And then 3i times negative I would be negative 3i squared. Okay, so what we need to do is combine like terms. And also we know what I squared is. I squared is negative 1. And so we have to substitute that in to get rid of that. Okay, so 10, bring it down. We can combine negative 2i plus 15i to get 13i. And then our I squared, like we said, is negative 1. And so that would be the same thing as just replacing that with the negative 1. We're going to substitute that in. Okay, now this can simplify. And so we have negative 3 times a negative 1 gives us a positive 3. So that would be 10 plus 13i plus 3. 10 plus 3 is 13. And now this is in standard form. If you notice, there is no I squared in standard form because I squared is negative 1. And so you have to substitute that in order to get your A plus BI standard form. Okay, let's do another one of those. Wow. Surprise, surprise, I think my smartboard is stopping to. Okay, so we're going to multiply. So we have 2 times 2 would be 4. 2 times negative I would be negative 2i. And then we have 3i times 2 would be 6i. And then we have 3i times negative I to be negative 3i squared. Okay, so 2 things that I'm going to do in this next step is I'm going to combine my like terms, my middle I terms. So we have 4. And then we have negative 2 plus 6 would be plus 4i. And then our I squared, I'm going to replace to be negative 1. So minus 3 times negative 1. Okay, negative 3 times negative 1 is a positive 3. So if you want to skip that part, whatever you want to do, that's fine. We have 4 plus 4i plus 3. Combine those to make 7 plus 4i. So our real number here is 7. Our imaginary is the 4. So we have the A and the B, that's in standard form, so you're good to go. Wow. Okay. So now let's talk about complex conjugates and divisions. So if you recall, you can't have a radical in the denominator, okay? Kind of like, you know, another fun fact, you have a 0 in the denominator, you can't have a radical, you can't have an I in the denominator. So we will have to be multiplying by our conjugates and division, okay? So the product of the complex numbers a plus bi and a minus bi is a positive real number, okay? Positive real number. And so if we have a plus bi and say that's in the denominator and we want to get rid of it, we can multiply times the conjugate, which is all it is we change the sign here. So if this is a positive, this would be a negative, and vice versa. If this was a negative, this would be a positive. Okay, and by doing that, we square our a term, and then you square your b term, and you add them together. And so this kind of simplifies to be a squared plus b squared. And so the reason why we have to do that is because you cannot have a I in the denominator. And so the complex conjugate of z plus bi would be a minus bi. And so again, it's always a positive whole number. So let's practice finding just complex conjugates. So we are going to find the product of the complex number and its conjugate. And it's always just a positive whole number. Okay, so if we have 2 minus 3i, so I'm going to do it the long way for 1, and I'm going to kind of show you the shortcut for number 2. So for number 1, if we have 2 minus 3i, the complex number and its conjugate would be 2 plus 3i. Okay, so if we multiplied those together, 2 times 2 would be 4. 2 times 3i would be 6i. Negative 3i times 2 would be negative 6i. And hopefully you see a little bit, like those are going to cancel. And then a negative 3i times a 3i would be a negative 9i squared. Okay, so two things that we do, we combine our middle terms of our i's, and then we replace our I squared with a negative 1. So we have 4, and then negative or positive side minus 6i, those cancel. And then we have a negative 9 times a negative 1. Well, negative 9 times negative 1 is a positive 9, so that would be 4 plus 9. That equals 13. Okay, so your conjugate in the complex number would be 13. Okay, a little trick or a little shortcut is we square your a, we square your b, and we add them together. And so if you look at a, our a here is 2. 2 squared is 4, and then plus negative 3. Well, negative 3 squared, anything squared is always a positive, so negative 3 squared would be a positive 9. 4 plus 9 is 13. Okay, so that's kind of your shortcut. But that's why we do it, is to get rid of that I in the denominator. So if we look at number 2, if we do our shortcut, if we do our a squared, which is negative 3 squared, plus our b squared, which is 4 squared, okay, negative 3 squared is 9, plus 4 squared is 16, that would equal 25. Okay, and so that's how you can find the product of the complex number and its conjugate. And that will come in handy. Y'all, this smartboard. And they came and worked on it the other day. That's okay. We're rocking and rolling. Okay, so whenever we're dividing complex numbers, we have to do the conjugate. Because you can't have an I in a denominator like A and B, we can't leave them like this. You can't have an I in the denominator. So we need to multiply the top and the bottom by the denominator's conjugate. So this first one, we have 2 over 3i. So the conjugate would be 3 plus I. Okay, what you do to the bottom, you have to do to the top. Okay, so we multiply the top and the bottom by its conjugate. So if we do that here, which is what they did. So 2 times 3 would give us 6. 2 times I would give us 2i. And then if we do the bottom, we have our 3 squared plus 1 squared. So 3 squared would be 9, plus 1 squared would be 10. So then this would be written as 6 plus 2i over 10. Okay, and this is technically not in standard form because it's not written in a plus bi. So we need to break up those two fractions. And so we're going to take 6 divided by 10 here plus 2 over 10i, and then we can simplify those fractions. Okay, so 6 over 10 simplifies to be 3 over 5, and then 2 over 10 simplifies to be 1 over 5. Okay, so now let's do another one. So we have an I in the denominator. We can't have that, so we need to multiply the top and the bottom by this conjugate. Okay, so if this is 2 minus 3i, the conjugate would be 2 plus 3i. Okay, what we do to the bottom, we have to do to the top. Okay, so now we distribute. 5 times 2 would be 10. 5 times 3i would be 15i. I times 2 would be 2i. and then I times 3I would be 3I squared. Okay, and that's over. So we can, if you need to like multiply it out, you totally can. I'm just gonna square 2, so it'd be 4 plus 3 squared would be 9, 4 plus 9 is 13. So this denominator would be 13. Okay, I'm gonna simplify that. 2 terms in the middle, so 15I plus 2I would be 17I. And then this would be 3 times your -1, okay? So if we have 10 plus 17I and then minus 3 over 13, okay, 10 minus 3 would be 7 plus 17I over 13. Okay, we're almost done, but we have to break up these A and the B and divide it by 13. So A is 7, so we have 7 over 13 plus 17 over 13 I. And that would be your answer in standard form. I don't know why I keep trying that, because that's not going to work. Okay. Now let's talk about complex solutions of a quadratic equation. I could spend like a whole day just talking about the discriminant and what that means. So if you recall your quadratic formula, which we're going to use in a second, your discriminant is what is under your radical. And that tells us if you're going to have either 2 solutions, and remember solutions are x-intercepts. So this will tell us if you have 2 solutions, 1 solution, or no solution. Okay, so if you do your discriminant and you get a number that is greater than 0, then that means that there are 2 distinct real solutions. That means your graph is going to cross the x-axis twice. Okay, if you do your discriminant and you get equals 0, okay, that means that your origin or your vertex is on the x-axis. That means you only have 1 solution. Okay, and then if you do your discriminant, you get a negative number. Okay, if we get a negative under here, well, we can't take the negative of a number. So like the negative, say we got -4. Okay, the discriminant being -4 tells us that there is no real solution. It's never going to cross the x-axis. Square root of -4 would be a positive 2i. Okay, and so that kind of talks about it right here. The why and the how, the discriminant tells us if you have 2, 1, or no solutions for your quadratic. So let's talk about solving a quadratic. So solving the quadratic equation, so we have x squared plus x plus 1 is equal to 0. And so we're going to solve this quadratic equation using the quadratic formula. And I love using the quadratic formula. I mean, even if it could be factored like 9 times out of 10, I'm going to start with the quadratic formula because everything can be solved by the quadratic formula, even if there's no solution. Hint, hint, probably this one. So we have A is 1, B is 1, and C is 1. Okay, so I'm going to fill out our quadratic formula. We have x equals -1 plus or minus the square root of 1 squared minus 4 times 1 times C, which is also 1. All of this is over 2 times A, which is 1. Okay, so if we plugged in this 1 squared minus 4 times 1 times 1. Well, 1 squared is 1 minus 4 times 1 times 1, which is just 4. So we have -1 plus or minus the square root of 1 minus 4 over 2, which 1 minus 4 is -3. So we have -1 plus or minus the square root of -3 over 2. Okay, so your discriminant is this b squared minus 4a times c. That we got is -3. So that tells us there's no solution. This is not going to cross the y or the x-axis because we have the square root of -3. Well, that's an imaginary number. There is no real solution. Okay, so what we need to do is we need to take the square root of -3, okay, which is the square root of 3i, okay? So we take our I out, so this is -1 plus or minus I square root of 3 over 2, okay? And so what we need to do is we need to write this in standard form, a plus bi. So we're gonna break this up. We're gonna divide each of these by our 2. So we have negative 1 over 2 plus or minus, our b is the root 3 over 2, and then our I, our imaginary number, okay? And that right there, x equals. And so the reason why you know that there is no solution or there's no real solution, because we have an imaginary number. It's not going to cross the x-axis at any point. So if we graphed this line, it would not cross, okay? That is it, I'm pretty sure, for this lesson. There's 15 total questions. I think you guys are going to be good. It's a fairly simple lesson. Email me if you have any questions. Bye.